Hello and welcome back to another video. In this problem, we are asked to start with the graph of y equals e to the x and write the equation of the graph that results from all of these transformations. So we're starting with y equals e to the x. For a, we are asked to shift 2 units downward. So a shift means we are going to be adding or subtracting some value. Downward is vertical, so it's going to be outside the function. It being downward and not upward means it's a subtraction, so this is y equals e to the x minus 2. This is contrasted with it's a horizontal shift to the right, which means the subtraction is being done within the function. Y equals e to the x, and then it's to the right, so it is minus 2. So these are the two types of shifts. Right? A vertical shift, upwards or downwards, you calculate the function, e to the x, and then you subtract 2 at the end. In a horizontal shift, like to the right, you subtract 2 from the variable immediately, and then you calculate the function. For C, we have reflecting about the x-axis. And in D and E, we have y-axis and then reflected against both. So reflecting against in any way means we're going to add a negative sign to the function. And is it, writing up here as an example, is it y equals negative e to the x or y equals e to the negative x? I think the easiest way for me to remember this is if you take the graph of y equals x squared, to make it flip across the x-axis, you have to put a negative out front. If you put it within the function and square the whole negative x, you just get x squared. Which makes sense because if you reflect this against the y-axis, since it's symmetrical, you're not doing anything to it at all. So, to reflect about the x-axis, like we do here, we have to put the negative sign outside of the function. And for D, which I'll write up here so we don't run off the page, we are doing the opposite, right? We are reflecting over the y-axis, so you put the negative inside. Y equals e to the negative x. And then finally, E, you just have to do both. Negative e to the negative x. So starting from this original graph, this is how you apply all the transformations in equation form.